Hi everyone. In this video we're going to look at nonlinear systems of equations. So remember, when we're solving a system of equations, we're looking for where two different functions intersect. What points do they have in common? So before, we were looking at lines where they intersect, but the functions could be anything. So here you have a circle and this function over here, which is called a hyperbola. And the solution to the system of these equations would be wherever they intersect. So it would be here, 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 and here. Okay, so when we're looking at linear systems, you're looking for one point where they intersect. Something that's different in nonlinear systems is there might be one intersection, 2, 3, or 4, or maybe even more. So keep that in mind, and we'll take a look at what this looks like algebraically. So if I say solve the systems of equations, the good news is you actually already know all the methods to take. On a nonlinear system, the methods are still graphing, substitution, or elimination. So like I could look at this graph and say, oh, that's about -4 and then 2 point something, -4 point something, 2 point something. I don't know. So that's why I might not want to use graphing on this problem, and I'm going to solve algebraically. So I'm actually going to show you how to do this with substitution or elimination, so you can use both. Okay, so if I was going to use elimination, they would need to cancel out. So, I could make this a -4x, or I could cancel the y's and make that a 9. Just pick something strategic. And for me, that would be multiplying everything in the second equation by 9, because then I'll have a positive and a negative 9y squared. So if you do that correctly, you'll get 9x squared plus 9y squared equals 225. And I don't even need to do anything to the first equation because I already have terms that will cancel when I do elimination. So I'll leave that as 4x squared minus 9y squared equals 36. Although sometimes you will have to multiply both equations, just like a linear system. So then I could add these guys together, and these y squareds will cancel out. So I have 4x squareds and 9x squareds. That gives me 13x squareds. And then I have 225 and 36, which gives me 261. Next, you're going to solve for x. So the only difference is this won't be linear, and there's going to be an extra step you have to take as a result. So as you kind of saw, this set of equations actually matches the graph above, and those intersections were not at whole numbers. So it's okay if you don't get whole numbers. Just go with, your good math sense here. And I'm going to leave that as a fraction. And then to isolate that x, I still need to take the square root, which when you're taking square root, remember, it could be a positive or a negative answer. So I'll leave that as the square root of 261 over 13, which we can also plug in our calculator to figure out what that is. So 261 divided by 13 gives me that. I take the square root of that. I get about 4.48. So I'm going to give you the exact and the approximate. What did I say it was? 4.481. I'll go to 3 decimal places. Okay, so exact is usually better, but I wanted to give you both so you can see that, hey, the x value is going to intersect at both positive and negative 4.48. So here's negative 4.481, here's positive 4.481, and you can see that's where the intersections happen. Okay, so that's probably why graphing wouldn't be the complete best solution here. Okay, now we are going to plug it back in to find our y values. I'll pause the video and have you do that on your own, and I'll come back with the answer. Okay, I plugged in positive square root of 261 over 13, and you'll get approximately 2.2188. So I did round there, but I kept the fraction all the way through as its full decimal places, so I rounded the least amount. Okay, now technically x is plus or minus this, so I'd also want to plug in minus the square root of 261 over 13, but I noticed that it's being squared. So is my answer going to change, whether it's positive or negative? No, they'll both turn out positive because when you square negative, you still get a positive, which if you look at my graph, that makes sense. So the y values are actually exactly the same for this intersection here. Okay, but if you look back down at our answer compared to our graph, notice there's 4 intersections. Okay, but, if I'm thinking about setting these up as a point, I know my x coordinates are positive. Well, I'm actually going to write this as the decimal just for ease of writing. Positive 4.481, and my y coordinate would be 2.2188. That's 1 point. Okay, then, oops, I forgot my plus or minus here. I'd also have negative 4.481, 2.2188. That's 2 points, but I notice my intersections have 4 points. So the reason that is because, you know, when you're taking the square root here, you're solving for y, this would also need a plus or minus at the end. So that's just a good way, using your reasoning and sense making. How many answers should it have? Just watch your plus and minuses will be a very common mistake. So then I'd also have 4.481, 2.21, I'm going to round that to 9. And then, whoops, let's make that negative. And then I'd also have negative 4.481. I'm on negative 2.219. So there's my 4 intersection points and my 4 solutions. So this one has 4. They could have 3, they could have 2, they could have 1. You just want to make sure your algebra is correct to mirror the graph. And eventually you will learn how to graph these by hand so you can check your answers that way. Okay, so I do want to show you how to do this with substitution because either method is good. So I'm just going to erase what I had before. Okay, if you're a substitution fan, I just want to say you don't always have to get x or y completely by itself. So let's say I want to do substitution. I see these are probably the easier ones to isolate. I'm going to choose to isolate my y. So I'd move x squared over. X squared minus x squared is 0. So I get y squared equals 25 minus x squared. And you can actually do the substitution right from here. You don't have to take the square root and get y completely by itself because I know y squared is equal to this. Anywhere I see a y squared, I can replace it with 25 minus x squared, which I can do right here. Here's a y squared. I know that's equal to 25 minus x squared. So the substitution can look like this. 4x squared minus 9 times 25 minus x squared equals 36. So from here, you'll clean it up and it'll just be straight algebra solving, and the solution should be exactly the same as elimination. But I just kind of wanted to prove a point that substitution doesn't mean completely isolate a variable. Substitution means get something in terms of something else that you can use to replace an equation. So in this case, I see y squareds. I want to get it in terms of y squared. So just be creative when you do your substitution and know that that's an option. Otherwise, if you want to continue throughout this, feel free. You should get the exact same thing as elimination. Since you already know the solution, you can use that to check your work. So that's what a nonlinear system looks like. Really nothing new, just going through a problem and how to do a system of equations again. I'm leaving one for you to try on your own. I'll come back with the answer, but you should do this on your own. So, go. Okay, here's my solutions. You can take a look at them. I use substitution because I thought it'd be easier. So if you do that, I isolated x and I substituted for x here, which you see in this step. I squared that, which you see my work up here if you need it. That's a 45, which is how I got this. Then I didn't like the fraction in the denominator, so I cleared it by multiplying by y squared, which then I got this as a 4-3 function. I thought it might be nice to compare it to a quadratic, so I got it set equal to 0 because I actually can factor this, which you see here and here, and then I use zero product property to get y is plus or minus 3, y is plus or minus root 5, which then I plug back in to find my x values. And this is where it gets tricky in writing your answers. So this is my solution, right? And the tricky thing is you need to make sure your y and x go together. So like, for example, I wrote plus or minus root 5 here and plus or minus root 3, but that's kind of interesting. So in order to get plus or minus root 5 as my x, I would have had to plug in positive 3. So if I plug in positive 3, it would be 3 root 5 over 3, then my x would be root 5. So 3 and root 5 go together and they're listed as a point. If I plugged in negative 3, I would have got negative root 5. So negative 3 has to go with negative root 5. So when you're listing your solutions, just make sure they go with the one that you plugged in. If not, you might get way too many solutions. And if you look at the graph of this, which we will see right here in Desmos, you can see that there are 4 solutions. And you can kind of check your answers that way. So Desmos is a good tool for that. We will learn how to graph these by hand as well. So there should only be 4 solutions, and that is because you need to make sure the values go together correctly. So that's the on your own problem. You can pause at any time to go back and view my work. Otherwise, please come with questions.